Okay. Today we're jumping to chapter 7, and I know that because we're going to work on derivatives, and your book takes a break from that for a while. We're going to look at the calculus of the exponential function given f of x is equal to e to the x, which is the exponential function. E would be a number like 2.718. F prime of x is equal to e to the x. It's the best derivative you'll ever remember. You'll love it. Yep. The derivative of the function is itself, and we'll investigate why that is later on. But we start with example 1, and you need to be able to take the derivative of it. So what do I use? Product rule. So f prime of x is equal to derivative x to the third, 3x squared times e to the x plus x to the third times what's the derivative of e to the x? E to the x. No, not xe. There you go. Continuing to get back. Okay. If you look at, I want to look at this graphing calculator real quick, if it would just turn on. So, watch what happens here. If I look at the graph of y equals e to the x, I get second natural log, I get e to the. So if you look at y, I get e to the x. And what's interesting here is, if you look at the graph, let's suppose you find the value of e to the x at negative 0.5. If I go to my table and I type in negative 0.5 or negative 1, let's look at negative 1, I get 0.367. Well, the interesting thing is, if you look at the derivative, 6 at negative 1, is the derivative at negative 1 going to be positive or negative? It's going to be positive. You get 0.3678, which is exactly what your table value was. So that means that the derivative is equal to the function value. It's the only function, well, I should say that. It's the only function that I'm aware of where that happens. If we look at another one here, 0.5, the function valued at 0.5 is 1.648. So if you calculate the derivative at 0.5, you get 1.648. So wherever you want to know the derivative value at that spot, just look at the function value. So it makes it very unique, and it makes it easy to take the derivative of. So what would you do for b? When you have to set up the chain rule and you don't know what goes where, set up the inside first. What do you think the inside is? 4x squared. So what do you think the outside is? E to the u. Very good. Derivative of e to the u. Derivative of 4x squared. So you have 8x e to the 4x squared. Done. Let's look at c. What would you use for c? Yep. Some people don't like the quotient rule, and they only use the product rule and the chain rule. If you did that, you would have to write it like this. But I don't really like that, because then I have negative exponents. So this requires the use of the product rule and the chain rule, whereas this only requires the use of the quotient rule. So quotient rule, derivative of e to the x times 2 minus x minus derivative of the bottom and times e to the x, all over 2 minus x quantity squared. Now, before I showed you up above that if you have this, if you factor out e to the x, you can't combine any terms after you factor it out. Okay, nothing really. I mean, you could factor out a x squared e to the x, and you're left with 3 plus x, right? If you want to write the top like that, that's fine. Here, if you factor out e to the x, you do get some terms that actually combine. Take out an e to the x, and you're left with 2 minus x, what? Plus 1, which is e to the x times 3 minus x. I use the quotient rule. I showed you that some people don't like the quotient rule. They want to use the product rule instead. So if you brought it up the numerator, you could use the product rule with the chain. Any questions? Okay, if you can combine like terms by factoring something out, I would like you to do that. Let's try a difficult one. Those were easy. What about D? Chain rule. So if you set up the chain rule here, what goes on the inside? Goes on the outside. Derivative of e to the u. Derivative of 3 sine cubed of the root of x. This is where we separate the mice from the men. What do we put on the outside? Very good. 3u to the third. What are you taking to the third power? Sine of the root of x. Derivative of sine of the root of x. Chain rule. God is love. Yep, very good. Sine of u root of x. Derivative of sine of u. Cosine of u, derivative of the root of x. Over 2 roots of x. If we multiply those together, cosine will be on the top. We have cosine of the root of x over 2 roots of x. Now, I'm going to take this times that. So what am I actually squaring, the root of x or the sine? Sine. So it's 9 sine squared of the root of x times cosine of the root of x over 2 roots of x. Don't you dare cancel off the roots of x. Maybe in imaginary voodoo math land. Yeah. So now we can multiply everything together. What do I do with that 3 sine cubed of the root of x? I put it where u is. So it's going to be sitting in the exponent. So I'm going to choose to write this 9 piece first. 9 sine squared of the root of x cosine of the root of x all over 2 roots of x times e to the 3 sine cubed of the root of x, and that's the derivative. You can. All right. Do you see that you got to plug this sine back into here? So sine squared. It says u squared, so you're squaring the sine. So I've decided what your final exam will be. Your final exam will be you need to be able to take the derivative of anything that you see first semester, and you need to be able to evaluate any limit that you see. So limits and derivatives. Limits and derivatives. I'm saying that this is a legitimate problem too that you could see. I'm not going to put just cakewalk derivatives on there. Okay. All right. F of x equals the root of 4 minus e to the 4x. What do you do? Very good. To the 1/2 power. So you're going to use what? The beautiful chain rule. Our best friend. Do you appreciate now that the chain rule is what we probably use more than anything else? I mean, the chain rule is extremely helpful. And the derivative of u to the 1/2. And the derivative of 4, 0. So you know you're going to get a negative here. But remember that when you take the derivative of this, you just use the chain rule. What's the derivative of 4x? 4, and it's going to be negative, so negative 4. What's the derivative of e to the u? E to the u. So whenever you have the derivative of something with e, all you need to do is take the derivative of the exponent and move it out front. Makes it really easy, doesn't it? So now we multiply negative 4 times 1/2. So we get negative 2 and e to the 4x in the numerator. And in the bottom, see it, Amber? All right, and F. Whatever you want to do. Oh, we're in a Nebraska shirt today. So nice. We play the Gophers this weekend. So did the Vikings and the Gophers this weekend. Well, the score didn't say it, but Ohio State gave the Gophers the ball, what, 2, 3 times? And yet, I mean, it easily could have been a 4-touchdown game. What's that? Yep, saw that. Right here. 1/2 times negative 4 is negative 2. E to the 4x, and then square root of u is in the denominator. There you have it. Good to go? All right. Now, let's look at F. Uh, how should I treat A in this problem? It's just another constant. Just like pi is a number, A will be just a number. So we have the secant of e to the a pi x. Chain rule. What goes on the outside? Good. Secant of u. What goes on the inside? E to the a pi x. What's the derivative of secant of u? Derivative of e to the a pi x. What's the derivative of the exponent? A pi e to the a pi x. If you did the chain rule, that's what you would come up with. Sure. All right, so I'm going to multiply those two together. A pi times the secant of e to the a pi x times tangent of e to the a pi x. I have the e right. Oh, I'm sorry, I left something off here. This is just how I like to write it. I put the a pi and then the secant of e to the a pi x times the tangent of e to the a pi x times then e to the a pi x. So I like to put e on the very end. Yep. Your assignment right here. Yes. Um, we're now in the green book, so if you look back at my desk up in the cupboard up there, there's kind of, is it green or is it blue? What is that? Teal? So, no. We don't have enough. So, I made copies, but we won't spend a lot of time in that book, but we will spend a little bit. So I've run copies for you. If you actually want a book, then stop by and check one out sometime. If you want to do some light calc reading when you're at home. There's your assignment.